All right. So there we go. So 6.4%. So let's just start. Our goal is to get money going. But first off, we got to get percentages clear and all that. So write the percent as a decimal. Probably child's play for you. But I want to make sure and answer any little questions that still might be remaining about decimals and percentage. So how do you change a percent to a decimal? Yeah, so what do I do with the decimal point? Yeah, left 2 places, huh? Left 2 places. So the answer will become 0.064. We good? That you know already, right? I can turn on the lights a little bit. So 0.064. Right, now why? This is probably your last math class for most of you. Why? I think I mentioned it one time, didn't I, with percent? Why does the percent symbol move it back 2 places? I mean, I know you know it does, but why?
500.
Yeah, because it's 100, right, exactly, yeah, because percent, we'll do some language stuff here. Yeah, what cent? How long is a century? 100 years. It means per 100. In other words, it means divide by 100, doesn't it? And what happens when you divide a number by 100? That moves the decimal 2 places. It gets smaller, right? When you divide by 100, numbers get smaller. That's why the decimal goes back 2 places. Divide by 10, it goes back 1 place, 100, 2 places, 2 zeros, 2 places back. So that's why a percent symbol, notice it even has 2 zeros in it and a divide symbol. It's telling you, divide by 100. That's why the symbol is written that way. So that's what it means. So for example, let's make sure this is real, because, who cares about moving decimals? Real life. If somebody says, I was at the ball game, I was at the Dodger ball game, and 30% of the crowd was wearing hats at the ball game. What does that mean? 30%, like 30 people? No, it doesn't mean that. What does it mean to say at the ball game 30% of the crowd was wearing hats?
Out of everybody not wearing hats, 30% of them were wearing hats.
Out of everybody, the whole total, a certain group within the whole total was wearing hats.
But how many?
30 people for every 100.
There we go. Right? It means 30 per every 100. Meaning if you could break if you could take the hat wearers and spread them out evenly in the stadium, there'd be 30 hat wearers in every 100 people. 30 and 100, 30 and 100. That's what that means. That's what 30% means. It means 30 per 100. Are we good with that? So that's what percent really means. If you could spread out the hat wearers evenly in the stadium, then every group of 100 people you circled in the stadium, there'd be 30 hat wearers. And therefore 70 non-hat wearers. Huh? So for every 100 people, you'd find 30 wearing a hat and 70 not wearing a hat. 30 per every 100 would be hat wearers. Now, they're not really spread out evenly, but that's what we mean. If you could spread them out evenly, it'd be 30 per every 100. So that's what percent really means. 30% means 30 per every 100. That's why you divide by 100, and that's why the decimal goes back 2 places, because when you divide, numbers get smaller, don't they? Divide by 100, decimal goes back 2 places. So that's the exact same question. Yeah, so it randomizes it, but it randomed the same question. I'm going to skip that one. Let's go on to number 3. Write 9.75% as a fraction. Now we want to go to fraction. In fact, okay, so 9.75%. Now they want me to make it a fraction. We know we can make it a decimal by just moving the decimal back 2 places. But they don't want that. They want fraction. You'll be good as long as you're clear what a percent means. What does this little percent symbol mean? Remember, it's not just decoration. That's always my line. It's not an ornament on the Christmas tree. It actually has meaning to it. It actually has a meaning. What does it mean? It's per 100. Right? Percent is per 100. So in other words, this is 9.75 over 100. Right? Isn't that what that means? 9.75% means per 100 over 100. Okay, now that's a fraction, but it's kind of a weird fraction because it has like a decimal mixed into the fraction. We can't leave like decimal mixed into fraction, can we? So how do we get rid of that? How do we get that to not be a decimal anymore? What is there a way I could get that decimal to move to the right 2 places so it wouldn't be there anymore, just be 975? What will make that decimal, because I don't want that decimal on the top anymore, right? I just want a normal fraction without any decimals mixed in. That's what they want. When they say, give me a fraction, they mean, no decimals mixed in. So we're right so far, but we got to change the way it looks without changing the value. So how do I get that decimal to go to the right? Tyler?
The lower one, the 100, you also move like a decimal?
Yeah, just as long as you move the one on the top and the bottom the same, then then you haven't changed anything. Totally. Now, where is the decimal on the bottom? I don't see a decimal on the bottom. It's right here, huh? Isn't it? Like if somebody says, hey, the price on that whatever is $100. Somebody goes, oh, you mean like that?
No.
No, yeah, it's not the same, huh? We know where the decimal is, right? It's right there, isn't it? Right? Yeah. So if you don't see a decimal, it's really at the end. It's like a period in a sentence. If somebody forgets to put the period on the sentence, you know where it is. It's at the end. That's how a decimal is. If there's no decimal, it's really at the end. So I'm going to take so originally the one on the top was right here, right there. And the one on the bottom was right there. I'm going to move the one on the top 2 places to the right. Why? Because I want to make it just a normal number. I don't want a decimal. So if I move the one on the top 2 places, I must also move the one on the bottom 2 places. Now what happens when I move the one on the bottom 2 places? Because I don't want to change anything, right? I don't want to change the value. I just want to make it look different. Just one second. So if I move the one on the bottom 2 places to the right, what will become of that number? It'll add 2 zeros because it's going beyond the edge, huh? So it'll become 1 with 4 zeros. Everybody see that? On that? Why I want to move it to the right is because I want to make it a normal number. So in other words, so everybody hear Julie's question? I think it's a good one. If I moved that decimal to the left, it would become 0.975, which is still a decimal, huh? I don't want a decimal. I want a normal. See, they told me get a normal fraction, meaning no decimals mixed in. So the only way to get rid of a decimal is to move it to the right. If you move it to the right, then it's here. That's just a normal 975, right? When it's on the right, you can write the number without the decimal, and it's the same thing. So that's why. Good question. You move it to the right because that effectively gets rid of it, doesn't it? And that's what we want. We want to get rid of it. So long story short, I kind of made a long story out of that, but long story short, you take that 9.75, put it over 100, because that's what per 100 means. Move the decimal right 2 places to make it a normal 975, and the one on the bottom right 2 places adds 2 zeros. So it's 975 over, what is that, 10,000?
Yes.
Now, that is our answer, except that can be reduced, huh? You always have to simplify. You see it, simplest form? So how do you simplify that? Well, if you have like the Casio Natural Display Calculator, it'll just do it for you. Or a lot of other calculators. If you know how to use the fraction button, it'll do it for you automatically. Save you some time. One of those nice calculators, just type it in, it'll do it for you. If you don't, then you got to start dividing by things. What should you divide by? If you have to do it by hand, you have to divide top and bottom by same thing, right? What goes into both those? 5. 25 would be even quicker, but 5 will work. If you divide by 5, I don't know what that is. So 975 divided by 5. And 195 over, I don't know, that is 2,000, huh? Over 2,000, and then you got to do it again. Divide by 5 again. And you'll get 39 over 400. That's as far as it'll go. You can't divide anymore, which is the answer you guys were getting. So you just got to do it by hand if you don't have a calculator that'll do it automatically. Does that make sense? So that was a long problem. What did we do? We took 9.75%. Remember that percent's not just decoration. It has a meaning. It means per 100. So we put 100 on the bottom. Then we had to get rid of the decimal on the top. Getting rid of it means to the right. So I moved it to the right 2 places. I did the one on the bottom the same thing, because you got to do the same thing top and bottom so you don't change the value. That added 2 zeros to the bottom. Then I reduced the fraction. 39 over 400 is the answer to that problem. All right. Is that good? Should we move on to number 4? A student's score in a midterm exam was 26 out of 40. Express this as a percent. I think you can do that, right? Just divide it, huh? Yeah. It's 26 out of 40. Just divide, right? It's part over whole, huh? Just divide in your calculator. I don't know what that is. And now, on this one, I wouldn't use the fraction mode. Why not? Because they want a percent in the end, which means you want a decimal at first, then change to percent. So in other words, don't use the fraction button. Don't use the fraction button. Just do normal divide. Well, how do I know? How do you know which one? Well, it's because I don't want a fraction here. They're not saying, give me a fraction in the end. It's all about what you want in the end. They want a percentage, which is a decimal, basically. So just do normal division, you get decimal answers. Use the fraction button, you get fraction answers, right? So I just used normal division, got 0.65. Now that's not a percent yet. Here's the mistake I've seen a lot over the years. Students will do a good job, they'll divide that, they'll get that answer, and then they'll just type in 0.65. They're treating this percentage like it's a decoration. It's not. If it's there, it changes things. It has meaning, right? So if I'm going to put a percent on here, which I need to, they're putting it on there for me, it makes that decimal move 2 places, doesn't it? Right? So it's actually 65%, right? There we go. Just feel free to stop me if you want to talk more about it. 250-piece puzzle. We're going to get to money in a little bit. We're just warming up with all these percentages. 250-piece puzzles, missing 12% of its pieces. How many pieces are in the box? Kind of goes off the screen a little bit, but you can tell they're saying are in the box. So if it's missing 12%, 250 pieces, missing 12%, how many are in the box? I know you can. How y'all doing this one? Missing 12%, what'd you do, Josh?
You multiply 250 by 0.12.
Beautiful. Yeah, 0.12. Because, yeah, and let me write that out as a sentence. You're thinking totally right. 12% of the 250 pieces are missing, huh? Of always means multiply in math. Did you know that? Of is always multiply. So 12%, 0.12 of is multiply. So if you do that, somebody got an answer there?
30.
30, okay, thank you. So 30 are missing. That's the percentage missing, right? 12% missing, so 30 are missing. So how many are in the box?
220.
Yeah, subtract the 30, so 220 are still in the box. Is that good? Question? Jasmine?
I'm doing my homework right now.
Yeah.
Going along.
Sounds good.
Mine it's just different numbers but the same thing, and I got 280.
Number 6. Arvin's tuition bill for last semester was $57.50. If he paid $59.80 in tuition this semester, what was the percentage increase on his tuition? A little more interesting question. So now we're talking money a little bit. This is really the point of this chapter. To get more and more comfortable with money and percentage and all that, which we all deal with. So last semester $57.50 went up this semester to $59.80. What's the percent increase? That's what they're asking for, right? Percent increase. It went from, and let me just get a fresh screen here. Number 6. So it went from, what did it go from? $57.50 to $59.80. $57.50 to $59.80.
Yes.
Thank you. $59.80. Right. What's the percent? Percent increase. So what do y'all think? How are we going to figure out percent increase?
We've got to find the difference.
Good idea. Let's start with what was the actual increase, huh? Totally, Jesse. Yeah. So take the $59.80 and subtract the $59.50, huh? What do you get? $230? Yeah. So $230 is the actual dollar increase, right? Tuition went up by $230. And now they're asking us what is the percent increase. $230 is the dollar increase. How do we turn that into a percent increase? Any ideas? Josh?
Divide by 5,750.
So take the 230, right, over the 5750. So, now why? How do you know you're right? How do you know you divide by that one and not the last one?
That's the original number, and that's the difference between the two, so you can see how much
Yeah.
it is based on the original one.
Yeah. In other words, when somebody says they want to know the percent increase, they mean of the original. That's just what the sentence means. They mean the original amount, what part of that increased? That's what they're saying. That's the very meaning of the question. So you're always doing the part. Let me make explicit what's implied. We're always taking the part over the original. Exactly. That's what they're always meaning when they're talking about, and we're going to do a lot of that in this chapter. Percent increase. We're going to do really fancy ones. We're going to do inflation over 10 years, increasing each time. We get more and more fancy. So let's get the main idea. That's what is implicitly understood when people say percent increase. They mean the increase of the original. You got the original. What part of that went up is what they're saying. So you take the part that went up of the original, just divide it on your calculator. Just get a decimal right. We don't need the fraction button. We just want decimal because we're going to a percentage. So I'm doing my calculator now too. I'm getting 0.04, but that's not a percentage yet. So when I take the 0.04 and put the percent symbol on there, it's not just decoration. It does something. What happens? 2 places, 4%. That's a 4% increase. Because the $230 is a small part. It's 4/100ths of the 5750. Does that make sense? It's 4%. It's 400ths. Right? That's what percent means. If 4% of the crowd's wearing hats, that's 4 per every 100. Right? So this 230 is 400ths of 5750. So the increase was 4%, 400ths. So in other words, how much did the price go up by? 4 parts per every 100. So for every $100 of the original price, they tacked $4 more onto that 100. Next 100, $4 more. Next 100, $4 more. I want you to feel it. That's the more. I mean, I know it sounds funny, but math is about feeling it. I mean, no, it's just move this. Well, no, you'll know how to move those numbers around more if you feel it. If you really feel what's happening. That's what a 4% increase means. It means for every 100, they put 4 on every 100. 4 per 100. Stats, statistics? Oh, tax, yeah. Any kind of increase. So, so when that tax is certainly an increase, isn't it? Tali, you're right on the money. Yeah. Oh, that was.
How would you say that since it went up 40% in tuition?
Yeah, 4%. Yeah, just the tuition went up 4%. Yeah, 4 parts per every 100. All right, so over a period of 1 week, a stock index did the following. On Monday, the index went up 1.8%. On Tuesday, it went up 9.6%. Wednesday, it went down 3.9%. Thursday, it went up 0.9%. Friday, it went down 5.5%. What was the percentage increase, decrease of the index over the week? Wow. Good question.
Do you add up all the ups and then?
Because that's what it feels like we should do. But you can tell by my tone that's not what's truly happening. Yeah. Here, I assume that nobody could get this problem right now. Here I think we've pushed beyond normal, everybody's average ability to do things with percentage. I think right here we pushed out into the ocean now. Now we're out into real. This is where the normal person that hasn't studied a little higher math wouldn't be able to do this. Yeah, they would think you just add and subtract. Let's first off prove that's just not true. How do you I'm sure I'll give you particular skills, but better, why are we even doing any of this? It's to learn to think logically better, and you can improve at that. And what you like, one important thing, what math science people do when they read a question like this. Math science is not about being a walking catalog that knows all these little facts. No. It's about being a problem solver. And what it means to be a problem solver is you can read a question and you can logically approach it. So what I mean by logically approach it, if I read this kind of question on some high-stakes test I was taking and I really had to get it right, I would just be like, do you add them? Because I think that too first. I think, can you just add them and subtract them? And rather than just do that, I would test my ideas, right? It's the scientific method. Have an idea and test it. So let me go with you to testing this. I would make it, to test it, I'd make up something super easy. What if I had a price? What if I had $100? Super easy number, right? Let's start with $100. And what if I said it went up 50%? Easy now, I don't want 2.3% in those hard numbers. Let's just do something super easy. So I had $100, something cost $100, and it went up 50%. I can do that without a calculator. I think you can too, right? What would the new price be if it went up 50%?
150.
150, right? Just goes up $50, half. 50% is half, isn't it? So it goes up half. Okay, now let's say it drops back down 50%, because I'm trying to see if you can just like add them and subtract them. So now it's at 150. It went up 50%. It's at 150. Now let's let it drop down. Right? First day the stock went up 50%. Next day it went down 50%. So if you take that 150 and you move it down 50%.
$75.
Right, because half again. Right? Yeah, see, you got the math boom thing going. That's right. Subtract $75. It dropped, because that's half of it, right? 50% is half. So it drops down to 75. So the question is, it went up 50, down 50, and that's not zero. So, in other words, because I would have thought, had I never studied this before, I would think if you go up 50 and down 50, you're just back where you started. Not true. Look, not true. Huh? You go up 50, down 50, you're lower than where you started. So you can't just say, because I would have thought, plus 50, minus 50, 0. So we're back where we started, but not true. Huh? Not true. So see how I'm approaching it logically? I just take a real simple case, watch it out and go, oh, and then I step back and go, something's wrong in my thinking. And then I kind of break it down a little bit more and go, okay, why did that happen? Why didn't it go back to where it was? Well, because right here, the second time you did the 50, the first time you did 50%, half. First time you did half of 100, which is only $50. The second time you did half of a bigger number. Half of a bigger number is bigger. And you subtracted bigger amount than you added. You see that? So 50% of 100 is not the same as 50% of 150. Clearly, you know that. So that's the trick. We can't just look at percentages and say, oh, it's all the same, add and subtract it, because it's what the percentage is of. If it's of a bigger thing, that's more impacting than if it's a percentage of a smaller thing, right? 50% of my income is not like 50% of Mr. Gates' income, right? Those are not the same thing, even though the percentages are the same. So we can't just add, subtract percentages. We got to think about what percentages are really doing. Okay, so that's what we can't do, but that's important to know we can't do that. Well, then how in the world do we do this problem? Let me give you enough with the theorizing. Let me just jump right to a nice formula, and over time I'll make it make sense for you. Here it is. So for percent increase problems, I'm going to give you a formula which we'll always use for percent increase, and over time I'm trying to make it make more and more sense for you. It's going to be the new price, or whatever it is, we'll say price. The new price is 1 plus the percentage times the old price. That's for percent increase. And then for percent decrease, and they have both of them in this problem. For percent decrease, the new price, guess what it's going to be? Instead of 1 plus for increase, it's plus. What's it going to be for decrease? Minus the percent times the old. So these two formulas we're going to use a lot. Okay, so for example, if somebody says, hey, I've got a, well, let's do the $100 thing again. I got $100 whatever, and I'm going to increase it 50%, like we just did, right? How would you increase that 50%? Oh, you know what? Let me make one small addition. This right here needs to be a decimal. You've got to change that, percentage. We always change percentages to decimals when we use them, right? So those need to be decimals. Okay, so let's do it. So the new If you're going to take $100 and you're going to increase it 50%, we already know the answer. It's going to be 150, huh? But let's see it in action. Let's see this formula in action. I'm saying it's going to be 1 plus the percent times the old. So the new is going to be 1 plus, now what's the percent?
0.05.
Yeah, you got to make it a decimal. Beautiful. 0.50, huh? 50% made into a decimal. See, I'm saying decimal of the percentage. Times the old, what's the old price? Well, that's the $100, right? That's what it was before it was increased. And so then just use your calculator. What is 1 plus 0.5? It's just 1.50 times 100. The new price, hit the buttons on your calculator. Sure enough, there it is, $150, which we already knew. See how that formula works? It gives you the increase. What's the purpose of the 1? Why is there a 1 in there? The 1 gives you the original. Right? So I guess I can't resist just explaining the why right now. Why this works, the 1 gives you the original. Like you could do this by hand, right? Every one of you could do this by hand. If I said, hey, take $100 and increase it 23%. You would all know how to do that, right? You would take the 0.23 or whatever, 37, I'll just make up a new number since I wrote the wrong thing at first. 0.37, and you would just multiply it by 100. You'd get $37, and then you would add back the original 100, wouldn't you? To get the increase. Well, that's what the 1 does for you. It gives you the, because 1 times anything is itself. That gives you the original. So then the percentage is the increase, and you get the whole thing all at once. So that's why there's a 1 in there. It always gives you the original. All right, so with that in mind, let's go use it. So getting back to this, that was a lot of build up. Let's get back to this question. So over a period of 1 week, a stock index did the following. It went up 1.8%. So let me just write these down. Up 1.8%. And then it went up again 9.6%. I'm just going through the list here. And then it went down 3.9. And then it went up 0.9. And then down. Last one it went down 5.5. Okay, so we got to do all those. Well, first off, we've got to, we're basically going to multiply these all together is what it's going to be. Right, like I told you, the formula is the new price will be the old times these factors. So what's going to happen is we're going to take these various factors and we're going to say, okay, up by 1.8%. I'm going to change that to a decimal. What is that as a decimal? Move it back 2 places, right? This is 0.018. This is 0.096. This is 0.039. This is 0.009. See how that one went 2 places back, brought in 2 zeros? And this is 0.055. So first off, make them all decimals. Right? I just moved them all back 2 places. 1, 2, 1, 2, 1, 2. Is that good so far? Do you see why there's 2 zeros on the 9? Because, he went 2 places back. And, well, they all went 2 places back. But he was already at the edge, so 2 zeros came in. Good so far? I'm just moving all the decimals 2 places back to get a decimal. Okay, and this is up, up, down, up, down. Just putting positives and negatives. I'm not just going to add those up, though, as we know. It kind of looks like I am. I'm lining them all up vertically, but we're not going to do that, so I keep saying that, because it looks like I'm about to, but I'm not. And now, what do you do with the factors? You go 1 plus 0.018, 1 plus 0.096, 1 minus 0.039, 1 plus 0.009, and finally 1 minus, I'm running out of room here, 0.055, if you can read that. I should have started further left. But anyway, does everybody see that? Let me squeeze this in a little bit better. Everybody see that? So each of these pieces, I put a 1 in front because that's what I'm telling you in the formula. It's 1 for increase, it's 1 plus the decimal of the percentage. And for decrease, it's 1 minus the decimal of the percentage, right? So just multiply. Now, on this problem, they didn't give us an original price. They didn't say, originally the stock was at $970. What's it at now? They didn't tell me that at all, so you don't have to mess with that. Just this will take care of it. Just do this on your calculator. Is that making sense? Let's figure out each of these. I would just take my calculator and say, look, this is 1.018. This is 1.096. This one, subtract this on your calculator, you're going to get 0.961. This is 1.009. This one, subtracting your calculator, you're going to get 0.945. Does everybody see what I'm doing there? So I'm saying for percent increase, percent decrease, you just take 1 plus or minus the decimal versions, and then just multiply them all together. Just literally take your calculator now and just multiply all these decimals together. I'm going to do it as well. See what we get. Okay, so when I do all that, I got the answer of 1.02236,199. Did you guys get that? Multiply those numbers together on your calculator. So it became this. Okay, now what does that mean about like the final answer? Well, cut off that 1 in the front. Remember, that 1 was just what we were putting in every time. Don't worry about that 1. It's not really part of the final answer. What is then? It's the decimal that comes afterwards. So it's 0.02236199. They want you to change it to a percentage. So how do you change that to percentage? 2 places. And how many places? 1 decimal place. So 2.2%.
Why did you get rid of the 1?
Because the 1 is just something I added, right? Right there. It wasn't really part of the original question. It just helped us do the calculation, but it's really not part of the question. So just get rid of that 1.
Will that always be a 1? Will it ever be another?
Yeah. Let me give you real life on that. What if I told you I had $1 and it grew to become $1.12? What happened to it? It increased by how much money? 12 cents. See how we just cut out the 1? See, that's all I'm doing logically. I'm saying, look, the 1, you start with $1, it becomes $1.12. It's just the 12 that matters. Huh? The 1 was already there. That's just an increase of 12%. Now, what if the dollar became 0.96? That'd be a decrease. And how would you find the decrease? You would need to subtract. It'd be 0.04. So it's all about how far above the 1 it is or below the 1 it is for increase and decrease, isn't it? Right? If it's 12 cents above the 1, that's an increase of 12. If it's 4 cents below the 1, that's a decrease of 4%. This would be 4%. You see that? All right. So cut out that 1. This one is an increase. Increase by 2.2%. So all those factors of up and down, Monday through Friday, end up making a net effect of an increase of 2.2%. It's not by adding them, subtracting them. It's by putting them with 1s and multiplying them together. I'll try to give more logical reasons for that as we go. But for now, that's what'll work.
So the 1 is just kind of like a fill-in guy.
So number 8. Suppose that you deposit $4,000 in a savings account that pays 9% annual interest, with interest credited to the account at the end of each year. Assuming no withdrawals are made and that interest is compounded annually, Complete parts A and B below. Find the balance in the account after 2 years. Find the balance in the account after 6 years and 8 months. Okay. Yes. So here we go. So here's compound interest. Compound interest. I'm going to give you a formula. Let me write it here. So A equals P1 plus R over N to the NT. So again, I'm going to do it one more time. This is for compound interest.
So in this problem, n would be 1.
Yeah, n's just 1 in this problem. Exactly. So A is the amount later. P again is the principal now. Principal is the amount of money you put in the bank or the account now. R is the interest rate. N is the, again, number of compoundings per year. And here I'll do T. T is the number of years. Okay. So with that formula, I'm back over here. I'm going to use A equals P1 plus R over N to the NT. Let's plug some stuff in here. So they're saying you deposit $4,000, right? 4,000, yeah. $4,000. You put in $4,000. What is that? APRNT, what is that?
That's
4,000 is the amount you put in. It's the P, it's the principal investment. It's the amount you put in now. A is what is the amount it'll become later. Right? Y'all see that in the formula? I said the P is the principal now. The A is the amount later. So the principal is the 4,000. There's that 1 again. See how the 1 just keeps showing up? Because it just gives you the original. Next, what do they say? 9%. 9% annual interest. What's that?
R.
That's our interest rate, R. But you got to make it a decimal, huh? So 0.09. Does that make sense? R is 0.09. Now, what's in here? Is there anything about compounded annually? Like you have a birthday annually. How many times a year is that?
1.
1 time. N is 1. And N is 1 up here. And how many years is this? 2 years, at least on part A. 2 years. Like that. So you got to do that in your calculator. Let me help you. So this will be 4,000 times 1.09. 0.09 over 1 is just 0.09, huh? 2 that, and 2 times 1? That's just 2. So in other words, it's 4,000 times 1.09 to the second power. That's what you need to type into your calculator. Now, do you know how to do the second power button on your calculator? It's different on every calculator, but it's close to the same. It's basically going to be, you're going to type in 4,000. Let me bring it up here. And you type in 4,000 times 1.09. And then your power button is going to probably be like your X to the Y. On some calculators, it's an up arrow. Those are basically your Y to the X, X to the Y. It's going to be one of those 2 buttons, depending on your calculator. 2, and then hit equals or enter. And you should get an answer. And I'm getting, let me get this out of the way. I'm getting 4752.4, which means 40 cents, but you can just put the 0.4. Right? So it's $4,752.40 on that. Go to part B. Can do the same thing. Let me get it up here. So part B says find the balance after 6 years and 8 months. Now, what are you going to do about the 8 months?
Nothing.
Point.
Good job. How'd you know it, Eric?
Because they only get the interest after at the end of the year.
That's right. Wait. That isn't where it says it. There it is. Eric is reading careful, and that is a good way to go. See what it says there? Interest credited at the end of the year. So that 8-month thing won't do nothing, to use bad English. Won't do anything, right? Because if you don't get the credit till you get to if you don't reach the 7th year, That 8 months was for nothing according to those words, end of each year. So pretend they didn't even say that. Pretend they just said 6 years. That's all that's going to matter. Now that's not normally the way it is. This is like a trick where they're trying to trick you and throw a little curveball up there. You see that? So just do 6 years. Ignore the 8 months because they don't pay till you get to the end of the year. So they're tricking us. All right, same formula then. Same formula. A equals P, 1 plus R over N to the NT. So plug in stuff, hit the buttons on your calculator. In fact, everything's the same almost, isn't it? The P is still 4,000. The interest rate is still 9%. The N is still once a year. Now the T is 6 years. Hit the buttons. I'll do it too. I'm getting 6708.40. So the answer is 6708.40. Okay, number 9. So suppose that you deposited $35.70 on January 1st, 2005. Savings account paying 7.18% annual interest with interest credited to the account on December 31st of each year. On January 1st, 2007, you withdrew $1,700. And on January 1st, 2008, you withdrew $900. If you make no other withdrawals, what will be the balance in the account on January 1st, 2013? Yeah, not an easy one. Lavelle, you have the answer already. No, okay. So here we go. Let's take it piece by piece. So, in fact, why don't I write that out? 3570. So, yeah, I'm going to summarize this. This is question 9. So we start with 3570. Let me just clean it up. We start with 3570 in 2005. That interest rate. So in 2005. And what's the account? It's 7 1/8% annual interest. Yeah, so it's just once a year, right? There's nothing in here about compounding. It's just annual. So just once a year. So N is just 1. The interest rate is 7 1/8. All right. On 2007, how many years later is that? You withdrew 1,700.
2 years.
2 years. So withdraw. How much was that? 1,700. And that was January 1st, 2007.
It's 2 years after?
Yeah, exactly. That was January 1st, 2005, yeah. Okay, let's just do that step. Let's just do that first step. So basically we put 3570 in an account in 2005. It grows for 2 years, and then we pull out a chunk. So that 1,700, we're just going to need to subtract 1,700, right? Withdraw is subtraction once we've got the total. Does that make sense? We're just going to do the interest formula thing for 2 years, see how much it grows to become, and when we got that number, we'll just subtract the 1,700 they pulled out. Tracking with me? So let's use the same formula we've been using. A equals P, 1 plus R over N to the NT. So, what's the principal? Now this is the P, right? 3570. And what's the interest rate?
7.125.
Yeah. Good. Let me help with that. Yeah, so we have to take that 7 1/8%, it's like a mixed number kind of thing, and change that to a percentage. So let me help with that. So you got to take that 1/8. The easy way to go, there's some fancy ways, but let's just keep it simple. Just take 1 divided by 8. We know the 7's there, huh? We know the 7's there. So just leave the 7. Don't mess with the 7. Just go 1 divided by 8 on your calculator. 0.125, right?
Okay.
We good? And now that's a percentage still. I haven't moved any decimals yet. And then you know what to do when you move the decimal, right? It's going to go 2 places. So it'll become 0.07125. Is that good? So this will be 0.07125 over n. N is 1. T is 2 years. Am I going too fast? You tracking that? So see how we handle that 7 and 1/8? Just change that 1/8 to a decimal. Just divide it on your calculator. So I just took 1 divided by 8, and I got 0.125, and I put it right there.
And you use that whole long number.
Yeah, but you got to move the decimal back 2 places, like we always do. So you make it 0.0, right? Because I went 2 places back. So then it became 0.07125. Yeah, I got to use the whole thing. That's right. It was right here, and I moved it back 2 places.
Okay.
Good to there. So this will be.
Can we go back into chapter 8?
Change our mind, huh?
This is getting hard.
1.07125 squared.
Yes.
All right, so let's hit the buttons.
Okay, wait.
So I'm getting 4096. And then you got to round it. I got 848, but that rounds to 85 cents, right? Got to round nearest penny. How are we doing? You able to get that on the calculator? Now we need to make the withdrawal. Withdraw says your bank account grew originally from $35.70 to $4,000. By the way, look at that for a second. The account grew from basically $3,500 to over $4,000. It grew by about $500, a little over 500, $526 basically, right? But for doing what? Nothing. It just sat there, right? Einstein called compound interest the seventh wonder of the world, right? It's kind of amazing, right? That's what you're young. You've seen, and I'll try to show that. I'll try to show that you're young. No, I'll try to. What do I have? I'll try to show the growth. We'll do that probably tomorrow. You know, invest now. It's amazing what time will do to money for retirement. I mean, you're thinking retirement, Mr. Aaron. That's for most of you is way off. Yeah, but that's the whole point. You have an advantage. It'll build. I'll show some of those numbers. There was amazing what compound interest does over time. That's why Einstein called it the seventh wonder of the world. Anyway, all right. So our money grew from $3,570 to $4,000 whatever. And then we withdraw. So it grew for 2 years, got bigger, got to this 4,000 number, right? From 35 whatever to 4,000. Now we're going to pull out 1,700. 1,700 to buy that new computer, maybe. I don't know. Just guessing at the price there. So subtract that. What is that? 2396.85. Just subtract that in your calculator. So now there's $2396.85 sitting in the account because we pulled out 1,700, right? Now let's go. Then they have another step for us. We'll take a break after we finish this one. I promise. We're almost there. So now, you pulled that money out. That was in 2007. And then it just sat after that, sat in there. And then 1 year later, you pulled out another 900. Okay.
Let's do it again.
Yeah, but you got to let it grow for the year first.
Yeah.
Yeah, this is hard.
Wait. Say that
Yeah.
again?
So this is January 1st, 2007.
Right.
Now we got to go fast forward in time.
And that grows a year.
Yeah, exactly.
It's the interest.
Grows to January 1st, 2008. So we got to do 1 year of interest. So that 2,000 whatever is going to sit for a year and grow. Then we're going to pull out some more. So now we got to do the A equals P, 1 plus R over N, do the NT thing. A second time, there's a third time coming.
With the 2,396.
Yeah, with the 2396.85. Yeah, that's right. So let's do it. So the 2396.85, that's our P. That's now our principal. That's the money.
Not the start of 08.
That's the start.
That's the start of 08.
07. It's the start of 07, goes to 08. Right? We did the pullout in 07, and this was left at the start of 07.
Right.
And then it grew till 08.
So now we're at 2396 for the...
Yeah, it's going to grow to some amount at the beginning of 208. So during the year 2007 to the start of 2008, it grew.
2 years, you do it for 1 1 year.
That's 1 year, right? 2007 to 2008.
Got
1 year. Right? You with me?
Oh, yeah, I'm with you.
Good. All right. So 1 plus, and the interest rate, same interest rate. Just use that same number, 0.071. In fact, you don't even need the ends are 1 and everything, so just skip it. This is just going to be, I'm just going to save some time. Just going to be exactly what it was here. 0.07125, but it's to the first power instead of second, because it's only 1 year, not 2. Is that good? It's just 1 year, not 2. All the rest of the stuff is the same. And so, I don't know what that is.
2,567.6255, which we rounded to 63 cents. So 2,567.6255, but we rounded to 63.
Beautiful. 20, so it grew, our money grew a little bit for that year, a couple hundred. From 23 to 25. Okay, and then they make another withdrawal. Right? At that point, in 2008, you withdraw 900.
Okay.
So now, withdraw 900. So I've got to take that number, 25, 67, 63, and subtract, 900. And 16, 67, 63, I think.
Yeah, 63.
Like that. Right? That's our new balance. We have one more step.
What's the last step?
Then they're going to let it sit for about, I think it's 5 more years.
Okay.
Let me go down here. If you make no other withdrawals, what will it be in 2013? So now it sits from 2008 to 2013. So now after that second and last withdrawal of $900, then it sits for 5 more years and grows.
Right.
But now we just do 5 years of growth.
Yes, of that total.
So same formula with a 5.
1,600.
Yeah, of that total.
Okay.
So now we're going to take this new balance and we're going to just put it next to a 1.07125 to the 5th for 5 years of growth. So I'll go to a fresh screen here. So the new balance of 1,667, 63, let's see, 63, grows for 5 years to the year, what is it, 2013, is that what they said? Yeah, 5 years later, to 2013, right? So 5 years of growth, how do we do that? Same formula, A equals P, 1 plus R over N to the NT. Put in the principal. The principal is now the 1,667.63. This is going to be the same. I'm not going to mess around. It's 1.07125. But what's the time now? 5 years. Now it's 5 years. Hit the buttons on your calculator. I'm getting 2352.63. Yeah, did I do it right? Yeah. You guys getting that?
Not that, but I got this.
Yes.
Oh yeah, do you know how to do that?
No.
That means 11. We're talking about compounding and annual percentage yield. So APY is annual percentage yield. So what we want to do is we want to be able to compare loans. I know I skipped number 10. 11 will cover 10. 11 is all of 10 and more. So let's do 11 and we will have done 10 really. So, so what we're looking for here is how do you compare loans? Like if you're looking to get a loan or invest, either way, loan or invest, it's same, two sides of the same coin. all these say they're 14%, 14%, 14%, but this one's yearly, quarterly, monthly, daily, and then continuously. I haven't mentioned that one yet. Anyway, they all say they're 14%. Does that mean they're all going to pay you the same amount? Or if it's a loan, you have to pay the same amount? No. The compounding changes it a little. Not a lot, a little though. Basically, the more frequently they compound your money, the higher the rate actually is. So, this is important when it comes to money and lending and borrowing and investing. Is APR stands for annual percentage rate. Yeah. So that an annual. What's annual? Yearly, right? You have a birthday annually, right? Now. That's right here, APR. But APY, is annual percent yield. What?
Actual money.
Yeah, like what is it really doing?
So
in other words,
applicable in real life. Now we're talking money. Now we're talking about language, man.
Yeah. So what does it yield? What does it actually do? That's what we're really trying to figure out. They list the rate at 14%, and it is. I mean, quarterly, monthly, whatever. But what does it actually do to your bank account if you put money in at 14% yearly versus 14% quarterly versus those different ones? What actually happens? Well, that's what we're going to figure out. So it's called the APY. So the APY is what actually happens, annual percentage yield, what it actually produces. Well, how do you figure out what actually happens? Well, we're going to use the same formula we've been using, the A equals P thing, but again, I'm different than Math Excel here. So to find APY, and percentage yield, put in P equals $1 for T equals 1 year. For T equals 1 year. And then at the end, remove the 1 in the front and change to a percentage. Just like we did before, you cut off the 1 and you find out what happens to $1. So that's what we're going to do. In fact, so here we go. So I'm going to, the yearly, let's do the yearly first off. So if you're compounding yearly, what's in? Remember, in is the number of compoundings per year? 1. Just 1. If it's just yearly, it's once a year. What if you're quarterly? How many times per year quarterly? 4 times a year, huh? What if you're monthly? 12. What if you're daily? And we'll do continuously in a minute. That's special. Okay, so we're gonna use the formula for each. We'll start with the yearly one here, and we're gonna use A equals P, 1 plus R over N to the NT, and I'm gonna put in P is $1. So that's what I was saying. You let P be $1, and I'll explain why. Well, yeah, let me explain why right now. What if I said, hey, I've got this new fancy account, whatever, stock, blah, 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 and my $1 became $1.19 after 1 year. So if I put in my dollar in some account and that $1 became $1.19 after a year, how much did my money go up by? Yeah, so you just cut off the 1 in the front. See why I'm going to cut the 1 off the front and the end? Because I'm just looking for the effect upon my dollar, the yield. So that $1 yielded 19 cents, didn't it? And then change that. What is that in percentage?
19.
Move it 2 places, 19%. So you see, that's what we're so basically, if you find what happens to $1, you know what happens to every dollar. You know what the account's doing. Get the idea? That's why I'm putting in $1. For 1 year. If I find the effect on $1 for 1 year, I know the effect on every dollar. The Math Excel does some other thing, but I think this is the easier way to go. Just put in $1 for 1 year. Boom, there you've got the result. You've got what that account's actually doing to your money. No matter how they want to say it, that's the actual yield, right? Whatever happens to $1. Okay, so that's the idea. That's what we're going to do at the end. I'm just giving you the reason why this will work. So let's put in principal is $1. For time is 1 year. What's the rate? 14. Yeah, 14% for all of these. They're all listed at 14%. What's in for this one? It's just 1. And time is always going to be 1 year. We're putting in $1 for 1 year. So on your calculator, that'll be just like that. And I don't need a calculator to do that. 1.14 to the first power is just 1.14. The first one, we don't actually need a calculator. Everybody good so far? And so our $1 after 1 year became $1.14. So what do you do at the end?
Take off the dollar.
Cut out.
One.
It grew by 4, right? How much did it grow by? It grew by the 0.14, which is what percentage? 14%. So yeah, if you're just doing yearly,
It's always
they're the
gonna
same.
be the same.
Yeah. So in the future, we won't ever do that. For yearly, it's just automatically. It only gets more tricky when they compound your money more than once a year, which we'll now do the other ones. Does that make sense? If they just compound your money once a year, then what they're saying is what actually happens. They're saying, we'll give you 14% annually, once a year. So yeah, at the end of the year, they give 14%. No mystery there. But now, on the second part, they're saying, we're going to give you 14%, but we're going to do it by compounding quarterly. So that's going to be actually a little better than 14%. Or if it was a loan, it'd be a little worse because we're paying more. So let's do the second part now. So for the first part, annually, it's always the same. Yearly, it's always the same. So now, part 2, same thing. I'm going to put in, A equals P, 1 plus R over N to the NT. So I'm doing part 2 now, quarterly. I'm going to put in $1, right? Remember, for all these, we're saying what happens to $1. So put in $1. And the rate is 14%. But now, what is N for this part? 4. It's the first time we've had an N that's not 1. There'll be many more. So T is still 1. We're still doing 1 year. Tracking with me? Does everybody see what we put in there?
Yes.
So the N is 4. The T is still 1.
Oh, because it's still 1 year.
Yeah, still 1 year. Yeah, these will always be 1 year. It's always $1 for 1 year. That's always the same. P is going to be 1 in all these. T is going to be 1 in all these. $1 1 year. Yeah, so this will be, this is going to be 1 times, well, so I'm just going to put this in my calculator, basically. Just like that. So I would use, here's what you do. Here's the easiest way, I think, on the calculator. On the calculator, start on the inside. Meaning, I would start right there. Because I want to show you how to do it so you don't have to mess around with all those parentheses. Because that just gets tedious and easy to miss one and get it wrong. So here's an easy way. Just start on the inside. Literally just go 1 plus 0.14 divided by 4 and hit equals or enter. So I just do what's in the parentheses first. 1 plus 0.14 divided by 4 equals, what do you guys get? Something like 1.035? Yeah, 1.035.
Are we not making it where we move the decimals over like we did earlier? Make it 14 over 400?
400? Why would we do 400? It's just N is just 4?
You add 2,
No, that's just to, that,
so on your fraction there, 0.14 divided by 4?
right?
We don't want to make it a nice, pretty one with no decimals?
It was 14%. The decimal was here, and I moved it back 2 places to be 0.14. So it's already been moved. So yeah, so just on the percent. We only move decimals on the percent things. So on the 14%, back 2 places. Never on an in on that. So I can talk to you later about that. All right, so anyway, so we do the inside. So hit the equals right there. So we got, right now what we have is 1.035. You should have in your screen. That's what's in the parentheses, right? You guys with me?
Yes.
So type that's this. And now what do you need to do with that? Raise it to the 4th power. What you can do, what most, probably all your calculators, if you now just go up arrow or the X to the Y or Y to the X button, whichever one you have in your calculator, 4, and then hit equals, it'll take the last answer to the 4, it knows you mean the last answer to the 4th power equals. And let me see I don't know what you should get, 1.035.
It says do not round it to the final answers.
Yeah, that's why this is also good for that, because we're not rounding. So I'm getting 1.035. 1475,
Yeah.
2, 3, blah, blah, blah. Do you guys getting that okay?
Yes.
But what do we put?
So remember, and then remember what we do at the end. Like I wrote in the side, at the end, remove the 1. Change this to a percentage. How do you change a decimal to a percent? Because remember, our $1, this is what happens in this account. If you invest in this account at 14% compounded quarterly, your $1 will come out to be $1.14, blah, 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 blah. So a little better. It's a little more growth. So you cut out the $, because that was the original $. That's not growth. That was there from the beginning. We just want to know what was our yield, what was our growth. So cut off the $. In the front, right, like it says, and then move the decimal 2 places to make it a percentage. 4 point, how far do they want rounded here? 4 decimal places. 7523%. I didn't even, that'd be 14.7523%, if you can read that down there. So this one over here is 14.7523, or I can put it right here. 14.7523%. This one was straight 14. What that means then is that 14% compounded quarterly is actually, this is what actually happens to your money after 1 year. It really is a little better than 14%. It's 14.7523%. That's what it actually does. So if that was an investment, you'd say, yeah, I prefer that investment. It pays a little bit better than just straight 14. Or if that was a loan, you would say, no, I want the lower rate, please. This is a little higher. So it's what it actually is. APY is annual percentage yield, what it'll actually yield money-wise. The truth in lending laws in our nation say they have to list APY.
They have to list every single thing, because if not...
Yeah, even at the payday loan place. I don't know if people don't see that number. I don't know what's going on. But the APY, they have to list it, which is just so people know what's really happening, what this loan really is.
People don't know what that is. So
Yeah, maybe they don't know what it is. Yeah, that's right. So that's valuable to get it straight. Good, we got to do the other ones. They're going to all be the same, but let's do them. Monthly, well, the bottom one's a little different. We'll do that. Let's do the next one. It's going to be the same thing. We just keep putting in $1 for 1 year. So let's go to the monthly. So same formula. I'll do the monthly. A equals P. 1 plus R over N to the NT. And we'll put in, again, $1. The interest rate is 0.14. And now for monthly, what is in? 12 times a year, right? If they're compounding your money monthly. And the N goes in 2 places, doesn't it? Inside the parentheses, and then up there, and then the T, that's 1 year. We're seeing what happens to $1 after 1 year. Then we'll know what's really happening to our money. Okay, so same kind of thing. I would start with the inside, just put that into your calculator, and hit enter, right? Getting the idea of how I do that? Just type in 1 plus 0.14 divided by 12 equals. So then you've got that whole inside, and then go to the power 12 equals, or maybe your power button is x to the y, whatever your power button is.
Because it's monthly, so there's 12 months in a year.
Yeah, the 12, monthly is, it's on the sideboard too. Monthly, it means 12 times a year. So if somebody does something monthly, they do it 12 times a year. And to the 12. So I'm getting 1.149. 149. You got to write a lot of decimals here. 342029. Okay, and then what do we do with these numbers? Remember, that's what's happened to $1 after 1 year. Our $1 after 1 year became that. We just want the growth.
You just want that
So drop that, because that was already there from the beginning. That's not growth, right? We just want the growth, which is the decimal part. And then how do you turn that decimal? Just 2 places, huh? Always going to be 2 places. So 14.9342. They want 4 decimal places. 14.9342%.
Got it.
You would round. Yeah, the next digit was a 0. So it just stays as it is. If the next digit was a 5 or something, then I would have rounded up.
I get the one thing now, because we just plug in the 1 to, like, I don't know how to word my words, like measure out.
Well, the $1 becomes $1
Yeah.
and we just care about the and, because we just want the growth.
So
That's
we're
all.
using it
They're
as a
just,
form of measurement.
well, they're just asking us,
Yeah.
how much will your dollar grow by?
Yeah.
So if my dollar becomes $1.14, it just grew by the 14.
Okay, yeah, I get it.
Yeah, it's just the growth. All we want is the growth on the dollar, the yield. What does that dollar yield?
And when
How
we
much
know
interest?
the $1, then that goes to all the dollars.
Yeah, if you know what happens to $1, you know what happens to every dollar.
Okay.
Yeah, exactly. All right, so now how about daily?
So we do 365.
So it's on the sideboard. Yeah, daily's 365. We're assuming no leap year. 365. Let's do daily. So daily. So I'm going to do the same thing. A equals P. 1 plus R over N to the NT. So the principal investment, again, $1. Interest rate, 0.14. So number of compoundings for daily. So if you say, I do something daily, then you do it 365 times a year. 365, 365, and T is 1 year. So, Erica, I'm not sure how you're going to do the 365 power here.
So what I did, well, I was trying to do it all in one formula. So what I literally had to do was just do the brackets first, press enter, and then do my exponent after.
Okay.
Because then instead of it having the long, I just rounded it.
Okay, so type that in. So we start with the inside, right? So type in the inside, 1 plus 0.14 divided by 365. Type this in right here. And then when you're done with that, go to the power 365 equals. And you should get some number.
Nope.
To the power, or x to the y. And I'm getting 1.15024 2923.
Yes.
Guys getting that?
Wait, how many do you go by?
Well, just write all you got, and then let's go through the steps. Eventually 4, but not right now 4. We have to go through the steps.
Wait, what?
Drop the 1. Let's just go through the steps. Drop the 1, because we just want the growth. We don't want the original dollar. It's been there all along. We just want the growth on the dollar. That's what they're really asking us. What's your growth? So then we do you got a decimal number now. Change it to a percentage. 2 places. 15.0242923%. Now it's a percent. Notice when the percent shows up on the scene, the decimal moves. Right? It's not a decoration. It has effect. Right? Now, how many places do they want? 4 places. So circle the number that's in the 4th place. Got to round here. 1, 2, 3. It's this number. Isn't he the 4th decimal place? See, they're saying 4 decimal places. So circle the number. Remember how rounding works? And not all that weird rounding we did for Jefferson Adams, but just normal rounding. You just circle the place you're going to stop at, 4th place. You look 1 to the right, and if that 1 to the right is 5 or more, you go up. Otherwise, you leave it. You know that. Just normal rounding, right? So 0.0243, huh?
Okay.
Percent. So there it is. 15.0243. What were the other percentages? It was 14.9342. I just want you to see how they're getting higher.
Are we always gonna go 4?
14.7523.
No, it'll tell you.
Yeah, they'll just tell you.
Okay.
See how they've been getting higher and higher? So in other words, the more frequently you compound the money, the higher the actual effect. In other words, doing 14% daily is the same as if they just gave you 15% once a year. It's the same. That's the real effect. That's what will really happen on your money. Finally, continuously.
Is that like forever?
That's infinitely fast. So how can you compound money infinitely fast? Not just once a year, or 4 times a year, or 12 times a year, or even every day, without break. continuously. Now,
That'd be like stocks.
it's a fast banker. Fast. No, I'm just joking. I'm
Oh,
joking.
okay.
It's-
Okay, I didn't know that existed.
Yeah, no. It's just a different kind of compounding. There's just a special formula. So let me just give it to you. Continuous compounding. It's just another kind of compounding. It does mean super fast, but there's a special formula. P-E to the R-T. It's a different formula. So let's do continuous. So for continuous, we're going to use a special formula. Okay, so now everything else is the same. Like $1 1 year. It's all the same. We're putting in one, because that's how you find the actual effect of anything. Any account. Think about it. That makes sense, right? If you find out what happens to $1 after 1 year, you know what that account's doing. So put in $1, and what's the interest rate? Still 0.14, and put it in for 1 year. So I put in $1 1 year. Now, how do you do that on your calculator? So that's going to be 1e to the 0.14. You don't need that 1 in the front, right? 1 times anything is itself. So I'm going to skip the 1 in the front. I'm going to skip the 1 in the power. 1 times 0.14, that's just 0.14, right? Nothing important there. So you just basically have to find that button on your calculator. It's usually above the LN button. You normally have to hit second LN or inverse LN. And then 0.14 and equals. Usually. Now some of the calculators are backwards. You got to do that backwards. Sort of depends. I can help you. So for most of you that'll work perfect. I'm getting 1.150273799.
That's what, 15%?
Yeah. So and then we end it the same as we did all the other ones. You know what to do now. Cut off the 1. Right. The $1 became $1.15. Blah blah blah. So what was the growth? Well, cut out the dollar. The growth was the 0.15. Blah blah blah. Move the decimal 2 places because you got to make it a percentage. 0.2737999%. They want the answer rounded to 4 places. So go to the 4th place, circle the 4th place, look 1 to the right. If it's 5 or more, round up. 0.0274%. 15.0274%. So that's even a little higher than the last one because it's more frequent compounding.
Okay.
You finding that button? Okay.
What is EVO? Like, what is that?
All right, so here we are in number 12. If an investment has 7.25% APY, notice that's APY,
Yes.
right? It's not APR, meaning that's the actual effect. That's the real deal there. Annual percentage yield.
We have to work backwards.
Oh, we're not going to do all that.
Oh,
Well, if they asked us for the original, we would, but they're not going to ask us for the original.
okay.
They're just going to say, hey, take that, and then how many years will it take for you to double your money? Well, have you guys heard of the rule of 72? The rule.
Yes. Oh, that's mutual funds.
You know that? Well, that's for any account that is for doubling money. The rule of 72 is the doubling rule. It's what investors use to figure out how long it's going to take them to double their money. So I'm just giving you a rule of thumb here. This is no extra charge. Real quick, 1 minute, because we got plenty of important stuff to do. But it's kind of nice to know. If you take any 2 numbers that multiply to be 72, like 9 times 8, or that's as much as I know, 4 times 18, or 3 times 24. There must be others. 6 times 12. You just keep going. All those numbers that multiply to be 72. If one of those is the percentage rate, and the other one is the years, and you could swap them up, that'll be really close. It's not exact, it's a rule of thumb, to doubling your money. So in other words, if you invest for 9 years money at 8% interest, it'll pretty much double your money, or vice versa. If you invest 8 years at 9%, right? If you have a higher interest rate, you need less time to double your money, right? If you invest at 4 years at 18%, if you can get 18% on something, it'll only take 4 years to double your money. Now, investors use the rule of 72, just so they can look at investing and go, okay, if I do that investment, that 18% thing, if I do that for 4 years, I'm going to double my money. It's really close to accurate. Gauss came up with it in the 1800s. It's super close to accurate. It's almost right on the money. So 6% for 12 years or 12% for 6 years, either way. Anyway, that's the rule of thumb. So, so if they're saying, hey, we're going to give you about 7%, let's just do a rule of thumb here. So we should think to ourselves, 7 times what number about is 72? Just have a ballpark on the answer. I know it's 7.25, close enough. I'm just thinking 7. About 10, 7 times 10, 7 times 11, somewhere between 10 and 11. So we're expecting an answer between 10, and 11, between 10% and 11%. Because 7 times 10 and the 70 is close to 72. So any two numbers, again, that multiply to be 72, they will, for time and percentage, double your money. That's for doubling your money. So I'm just expecting then that the answer is going to be somewhere 10 point something percent. Between 10 and 11, so that'd be 10 point something, right? So that's what I'm expecting. Anyway, not required. Let's do the problem now. So how do we actually do the problem, find the exact percentage? Well, same formulas we've been using. A equals P, 1 plus R over N to the NT. All right, so think with me for a second. They're saying take $2,000, put it in, invest, right? Invest $2,000 and double it. So if you're going to invest $2,000, your principal is?
Wait,
It's the $2,000.
but if it's between 10 and 11, can't you just say that it's 11 because 10 is going to be too
No, they want,
they just said at least.
oh, how many years? Round up. Yeah, it must be. Anyway, let's keep going, but I think good observation, Eric. Yeah.
How long do we have to double? Oh, that's
right.
what we're at. That's what we're.
So here we go. Yeah, so we're putting in $2,000. That's the principal. That's what we're investing, right? What do we want the amount to become if we want our money to double?
4,000.
You want it to become 4,000, huh? So they're actually giving us the other side, you realize. Doubling. We're doubling our money, right? 2,000 becomes 4,000. Okay. So then 1 plus R, what's the interest rate? Well, it's this, but you got to change it to a decimal, right? 7.25%, which is 0.0725. Move the decimal back 2 places. Right? That good? What's in here?
It's just
Annually. Just one, huh?
One.
Yeah. And how long?
You don't know.
Yeah, that's T. We don't know that. That's weird, isn't it? Time is what we don't know. We're wondering what is time. So we gotta find time. So 4,000 equals 2,000. Let me simplify this right side. This is just going to be 1.0725 to the T. T times 1 is just 1 times T is just T. Are we good there?
You do that.
Yeah.
You could. I'm not going to do that. I'm going to guess. I thought you weren't supposed to guess in that class. Well, I mean, we could formally solve it. You're right, Jessica. The first step would be divide. The next step is pretty tricky. You'd actually need to use what's called a natural log. We do that in pre-calculus.
Logarithm?
We don't want to go there, right? Are you with
That's
me?
another link, bruh.
But you're good with languages, right? That's your thing, man. Yeah, so we're not going to go there. I don't want to go to that whole thing. This isn't pre-calculus. You guys aren't moving on to calc. So just guess. Meaning, just put in, now that's why I gave you the rule of 72. What do we think the answer is?
10.
10
10 or 11.
10 or 11, we're thinking. So take your calculator and take 2,000 times 1.0725 to the 10th and see if it comes out 4,000 or bigger. If not, then do 11. Right? We're trying to see if it'll double our money. So pop in a 10 and see if it doubles your money. I'm betting yes, because that's not the answer. Barely. 4,027. I got 4,027 blah, blah, blah. No, that's it. That's our answer. It worked. That means 10 years doubled our money.
Oh.
Yeah, that's all we're doing. We're not doing anything more fancy than that. They're just saying, hey, how many years till you double your money? 10 years did? Now, if that had come out under 4,000, like 3,000 something, then I would have went up one more year to 11 years. Does that make sense? You just got to find how many years till the number comes out 4,000 or bigger. They're saying how many years till the 2,000 has doubled and become 4,000 or more. And we just popped into 10 and it worked. How did we know 10? That rule of 72 thing. We thought it was 10 or 11. So the answer indeed is 10. So 10 years. Now, what about the second question? How many years, if instead of putting in $2,000, you put in P dollars? How many are P dollars?
It's still gonna be 10 because it's like.
Yeah, doubling. It doesn't matter if you put in $1 and it became 2 or 2,000 became 4,000. It's the same. They're making sure you're good there. Doubling's double. Right? Doubling's doubling.